In this lesson, we will explore the determinants of a good regression. This video is based on the ANOVA framework you may have heard before. There are three terms we must define: the sum of squares total, the sum of squares regression, and the sum of squares error. The sum of squares total, denoted SST, is the square differences between the observed dependent variable and its mean. You could think of this as the dispersion of the observed variables around the mean. It is a measure of the total variability of the dataset. Here, I must say that another notation is TSS, or total sum of squares. The second term is the sum of squares due to regression, or SSR. It is the sum of the differences between the predicted value and the mean of the dependent variable. Think of it as a measure that describes how well your line fits the data. If this value of SSR is equal to the sum of squares total, it means your regression model captures all the observed variability and is perfect. Once again, we have to mention that another common notation is ESS, or explained sum of squares. The last term is the sum of squares error, or SSE. The error is the difference between the observed value and the predicted value. We usually want to minimize the error. The smaller the error, the better the estimation power of the regression. Finally, I should add that it is also known as RSS, or residual sum of squares. Residual as in remaining or unexplained. It becomes really confusing when I tell you that some people denote it as SSR, which makes it unclear whether we are talking about the sum of squares due to regression or sum of squared residuals. In any case, from prior experience, I know that neither of these are universally adopted, so the confusion remains, and we have to live with it. For your personal information, the two notations are SST, SSR, SSE, or TSS, ESS, RSS. There's a conflict regarding the abbreviations, but not about the concept and its application. So, let's focus on that. What is the connection among these three? Mathematically, SST is equal to SSR plus SSE. The rationale is the following. The total variability of the dataset is equal to the variability explained by the regression line plus the unexplained variability, known as error. Given a constant total variability, a lower error will cause a better regression. Conversely, a higher error will cause a less powerful regression. Makes sense, right? And that's what you must remember, no matter the notation.